So today we're going to talk about operations on polynomial expressions. So when you lift this first tab, first we're going to talk about how to add and subtract polynomials. So the first thing that we need to remember is that we need to distribute if necessary. Then we would combine like terms. And one thing that definitely I want you to remember, if you're subtracting polynomials, we have to distribute the negative and then combine like terms. So let's see some examples of that. So our first example looks like this. It says simplify the polynomial expression. And so we notice that I have a 2 out front, so that means I have to distribute that through this polynomial. So just through what's in parentheses. So this would be 2n squared minus 18n plus 6. Then we have a minus sign. And so I want you to think of this like a negative 1 that we have to distribute through. So negative 1 times negative 4n is positive 4n. Negative 1 times negative 8 is positive 8. Negative 1 times positive 3n squared is negative 3n squared. Now that we have everything distributed, we can just combine like terms. So I always start with the highest degree first. So the highest exponent first. So I'm going to box those in because those are like terms. 2n squared minus 3n squared is negative 1n squared. Negative 18n plus 4n is negative 14n. And then positive 6 and positive 8 makes positive 14. And so this is my final answer. This one says the perimeter of the triangle shown at the right is, and it gives us a perimeter. And it asks us for an expression for this third side. So this is a side we don't know. So we know when we do perimeter, we would add all three sides, and that gives us this. So one thing we could do is we could go ahead and add the two sides that we have here. So combine like terms. So x squared and x squared makes 2x squared. Negative 4x and negative 2x is negative 6x. And then I don't have anything to combine with this plus 3, so it just is plus 3. So this is the sum of these two. So what I'm going to do is I'm going to take the perimeter minus the sum of those two sides. So the perimeter minus the sum of the two sides that we know. So when I subtract, I have to distribute that negative sign. So I would get 4x squared plus 3x plus 1 minus 2x squared plus 6x minus 3. Now we can combine like terms. So I have 4x squared and negative 2x squared would be 2x squared. Then I have positive 3x and positive 6x is positive 9x. And then I have 1 minus 3 is negative 2. So that's adding and subtracting polynomials. The next that you see is multiplying. If I can find where it is, sorry. So multiplying, the steps are to distribute everything through. And a lot of times we're going to use FOIL. If we have a binomial times a binomial, this means first, outside, inside, last. So our example for that looks like this. It says determine the product. That's a fancy math word that means multiply. So we have to distribute the first number through everything, and then we have to distribute the second number through everything. So I'm going to do 4 times negative 2a squared is negative 8a squared. 4 times positive 3a is positive 12a. 4 times positive 2 is positive 8. Now I have to distribute this negative 1a through. So negative 1a times negative 2a squared is positive 2a cubed. So just a quick reminder, this has an exponent of 1. This has an exponent of 2. So when we multiply, we add the exponent. Negative 1a plus, times positive 3a is negative 3a squared. So again, that's a 1 and a 1, so that's how we get the squared. Negative 1a squared times positive 2 is negative 2a. So now that I have everything multiplied, I'm going to combine like terms. So I will start with my highest degree. So I would start with 2a cubed. Then I'm going to go to a squared. So I have negative 8a squared. Negative 3a squared would make negative 11a squared. Then I have positive 12a and minus 2a, so that's going to be positive 10a. And last I have positive 8, and there's nothing to combine, so plus 8. And that is my final product. Next is a word problem. The height of a triangle is this, and the base is this. Determine the polynomial expression that represents the area of the triangle. So area of a triangle is not on our formula chart. It's something that we're expected to know now. 1/2 base times height. So I'm going to do 1/2 times the base times the height. And what you're going to notice is we have 3 things that we're multiplying actually. So when we're multiplying, we can choose any 2 to multiply first. So I'm going to choose to do the 2 binomials first. So I'm going to FOIL first. First times first, so here's what I'm going to do, equals 1/2. I'm going to leave that 1/2 out there so I don't forget to multiply by it. 6n times n would make 6n squared. 6n times negative 6 is negative 36n. So that's the outside. Inside, negative 1 times n is negative 1n. Negative 1 times negative 6 is positive 6. Now I'm going to combine like terms in here real fast. So I have 1/2 6n squared minus 37n plus 6. Now I'm going to distribute that 1/2 through. So when I multiply everything in here by 1/2, I would get 3n squared minus 18.5n plus 3. Next is dividing. So when we're dividing, let's see if I can find my little notes for dividing. Step 1, or first, we're going to factor if possible and then cancel out common factors. So we'll do some examples of that. Or we could use long division or grid division, which we'll talk about in a little bit. Or if we're dividing by x plus or minus a number, so there's no coefficient in front of the x, we could use synthetic division, which we will also cover in just a second. So first example, it looks like this. Determine the quotient. So I see I have this and I have this. This is what it's dividing by. So just to be honest with you, if I saw this, I could use synthetic division. But I'm going to practice factoring for a minute, just because I feel like that's something we could all work on. So if I'm going to factor this first trinomial, I notice I have a 2 in front of x squared. So I'm going to see, can I divide everything by 2? And the answer is no. So I have to use what I call bottoms up to factor this. So the way you do bottoms up is you let the back number borrow the front number. And what we do is we rewrite it as x squared minus 11x. 2 times negative 40 is negative 80. Then I factor that. So I would get x times x is x squared. I know I have to have a positive and a negative to get a negative 80 product. And I need a negative 11 as the sum. So whichever is my bigger factor is going to go next to the negative sign because that's negative in the middle. So it turns out negative 16 and positive 5 multiplies to give you 80 and adds to be negative 11. But I'm not done because I'm doing bottoms up. I let it borrow a 2, so I have to divide a 2 out from both factors. This can't be simplified, so I'm going to bottoms up. So this is going to become 2x plus 5. This one I can simplify, so it's going to become x minus 8. So I factored this trinomial. So instead of writing it like this trinomial, I'm writing it like this, divided by x minus 8. So what you notice is if I have the same factor on top and bottom, I can cancel those out. And so what remains is my solution or my quotient. So there's that one. So we'll practice again. This time they gave us the area. They gave us one side. We're looking for the other side. So if you recall, if you have the area divided by the width, you could find the length. So I'm going to factor this trinomial. So it'd be x times x gives you x squared. What times what gives you negative 21. So I know it has to be a positive and a negative. And the bigger factor needs to be positive because the middle is positive. So I know 7 times 3 gives me 21, and if I made it positive 7 times negative 3, that would give me a sum of positive 4. So those are my factors. So since I'm going to do area divided by width, I would write the area divided by our width over here. And I'm going to cancel out any common factors, and so my answer would be x plus 7. So factoring worked on both of those, and so that's what's nice. It's actually pretty quick, but we're going to do some extra examples. So our extra examples are going to be covering long division, synthetic division, and then this grid division. So I'm going to use this as long division. So I don't have space here, so I'm going to just give myself a little blank canvas. So I had 6x squared plus 17x plus 20 divided by 3x plus 4. When we do long division, it's like back in the old day. We write it with the little division box, and we look at this front number and this front number. And I ask myself, 3x times what would give me 6x squared? So 3x times 2x would give me 6x squared. So since it's 2x, I'm going to write that answer above the x only spot. So if it has just an x, it goes above the x. Now I'm going to multiply. 2x times 3x is 6x squared. 2x times positive 4 is positive 8x. Then I'm going to draw a line. But here's the deal. We need to subtract. But when we subtract a polynomial, we subtract and change this sign. Now when we subtract down, this cancels, and it's 17x minus 8x would become 9x. And then I'm going to bring down the plus 20. So now I'm going to look at this front number and this front number. 3x times what would give me 9x? So 3x times positive 3 would give me 9x. And 3 times positive 4 is positive 12. Draw my big line. But I need to subtract. So I'm going to change both signs. This cancels, and I would be left with 8. So this is your remainder. The way we write the remainder is, since this is positive, I'm going to put plus 8 over whatever I'm dividing by. And so this is my answer using long division. So since this is EOC review, my positive advice is like, you could use any method you want, but what they could do is show you a problem and ask you where they made a mistake or what should be next or something like that. So I just wanted to show you long division. The next example is one that we're going to use for synthetic division. So if I have this, I can do synthetic division because there's no coefficient in front of this x. And so to do synthetic division, we draw a giant L, and we take the coefficients of all of the front, the trinomial that's being divided by. So 3, negative 10, and 20. So I just brought those down. Then here's the part that most people forget. Now I'm going to take this x minus 2 and change this sign. So it's going to become a positive 2 on the outside. Then I'm going to bring the first term straight down. So I bring down the 3. Then I'm going to multiply. 2 times 3, and I put that product here, which is 6. Then I'm going to add down. So negative 10 plus 6 is negative 4. Then I'm going to multiply. 2 times negative 4 is negative 8. Then I'm going to add down. 20 minus 8 is 12. So the way we write our answer is this is the remainder, this is the constant, this has an x. So our answer would be 3x minus 4 with a remainder of positive 12 over whatever we're dividing by, which is x minus 2. So that's synthetic division. I love this actually, and this will be used a lot in Algebra 2, as well as college algebra and stuff. Last one's the grid method. I don't normally teach the grid method very often, but I just thought I'd show it to you in case you're just completely freaking out about the other methods. So I just made this random example up. So here's how you would do the grid method. You would fill in, you would make a grid, and you would have 6x squared here, and you would have negative 12 here. And you know that one side of the grid is going to be 2x plus 3, and we're trying to figure out the other side of the grid, but we also know that we have this positive 1x, so we know these two numbers have to add to be 1x. And so here's kind of how I do it. So from here, I look at 2x times what would give me 6x squared? Well, it would be 3x. So then I'm going to use this 3x and do it kind of like you're multiplying a grid. 3x times 3 would give me 9x. So if I know that these two have to add to make 1x, I know this has to be a negative 8x. Now I can figure out the rest of my grid. 2x times what has to give me negative 8x. So that would be negative 4. But then I'm just going to verify by saying, hey, is negative 4 times positive 3 negative 12? Yes. So since this is this binomial they gave me, the other one is this.